Alright, so this is problem 9, and problem 9 reads, if f of x is this, x squared minus 3 divided by x cubed, then they give you f prime and f double prime, which is 9 minus x squared divided by x fourth, that's f prime. And f double prime is 2x cubed minus 36 divided by x to the fifth. Now, they want you to find on which intervals is f increasing and concave up. So on which interval is it increasing? Is it both increasing and concave up? Now recall that the first derivative test will tell us when f of x is increasing and when it's decreasing. So I wrote that down here. Now the second derivative test will tell us when f of x is on which intervals f of x is concave up and which intervals f of x is concave down. So I wrote that second derivative test right here. So what we need to do is we need to do both and compare them and see on which intervals they're both concave up and concave down. Okay, so let's go ahead and apply the first derivative test first. So first derivative test, take the first, you don't even have to do the first derivative of this, they give it to us. All we need to do is evaluate when it's 0 and when it's undefined. So when it's equal to 0 and when it's undefined. So when it's equal to 0, we make the numerator equal to 0. When it's undefined, we make the denominator equal to 0. So 9 minus x squared equal to 0. X to the fourth equal to 0. Okay, we obtain that x squared is equal to 9. And that means that x is equal to plus or minus 3. Take the square root of both sides, that's how we get plus or minus 3. So these are what we call the possible critical numbers, and here we get x equals 0. So these are possible critical numbers. However, we know that we need to evaluate these possible critical numbers into the original function to see if they're actual critical numbers. If we plug in 3, we're fine, because we don't get 0 down here, so we're good. If we plug in 0, we get undefined here, it's not defined. So 0 is not a critical number. Now that we have our two critical numbers, 3 and minus 3, we can go ahead and plot them into a number line and pick our test points. So minus 3 here and 3 here. Now I want to see if it's increasing and decreasing and increasing, or decreasing and increasing, whatever it is. But we're looking for increasing. So in the end, we really want to see when it's increasing. So let's pick test points here. Pick minus 4. I'll pick 1 here. And I'll pick 4 here. Okay, so how can I tell if it's increasing or decreasing? Well, I have to evaluate these test points into my first derivative. And we need to see the sign. The sign will tell us if it's increasing or decreasing. So now, plug in f prime, plug in negative 4 to f prime. So plug it in here. We get minus 4 squared is 16. 9 minus 16 is a negative number. And we get minus 4 to the fourth. Since this is an even power, this will be positive. So we have negative divided by a positive. That's a negative number. So this is a negative number. So it's decreasing. So we don't care about this. We only care when it's increasing. All right. So f prime of 1 now. So next test point. So plug 1 in here. See what happens. 1 squared is 1. 9 minus 1 is positive, and 1 to the fourth is positive. Positive divided by positive number. That's a positive number. So that's increasing. So that's good. From negative 3 to 3, this function is increasing. That's what we want. Let's go ahead and see what happens at f prime of 4. Okay, f prime of 4. We get 4 squared is 16. Top is negative. Bottom is positive. Negative divided by positive is a negative number. Alright, so from 3 to infinity, it's decreasing. So right now, what's important to us is negative 3 to 3. That's when it's increasing. It's what we want. Now we need to see when it's concave up. So to see if it's concave up, we need to apply the second derivative test. Okay, second derivative test. Okay, second derivative test. So second derivative test, same thing. Find when it's equal to 0 and when it's undefined. So we have 2x cubed minus 36 equal to 0. X to the fifth equal to 0. Alright, so now we obtain 2x cubed equals to 36. Divide both sides by 2. You get x cubed is equal to 36 divided by 2, that's 6 times 6, and that's 2. And then one of those 2 cancels with this, so we're left with 3 times 2 times 6. So we're left with 6 times 3, so that's 18. 12, yeah, it's 18, so it's 18 here. Now, take the cube root of both sides. Is that right? Yeah, that's a cube. So take the cube root of both sides. We get x is equal to cube root of 18. Well, we know 18 is 9 times 2. So 9 times 2, so that's going to be 3 square root of 2. Just make sure this is right. That's wrong, yes. So, sorry, this was a 2. So, this is wrong right here. Sorry about that, that should be a 2. Let's erase this. We're still going to get the same thing, it's going to be plus or minus. So I just missed a 2, I just remembered that wasn't a 3. That's actually a 2. Okay, so let's do this again. So we have 2x squared, that's equal to 36. Divide both sides by 2 again. So 2, 2. We get x squared is equal to 18. That's fine. Now we take the square root of both sides. Now here's the important part. We need a plus or minus. With a cube, we're not going to get that plus or minus. So we have x equals plus or minus 3 square root of 2. So how did I get that? That's the same thing as saying plus or minus square root of 9 times 2, that's 18, but the square root of 9 is 3. So we get x is equal to plus or minus 3 square root of 2. Alright. So these are our critical numbers here for the second derivative test. Now, let's evaluate this here. Here we go. So we have negative 3 square root of 2 and 3 square root of 2. Okay, and by the way, here we have x to the 5th equals 0. We gotta make that equal to 0, so that's when x is equal to 0. However, when x is equal to 0, you evaluate 0 here, it's not defined, so that's not a critical point. Our only critical points are these. You plug them in here, they're defined, you'll see. So that's why I'm only choosing negative 3 square root of 2 and 3 square root of 2. Now, I'm going to pick test points again. So let's say I'll pick minus 6 here. And I will pick, let's see, what's our interval here? Negative 3 to 3. Let's pick negative 1. Because that's between, yeah. And let's pick here, let's see. Well, 3 square root of 2 is definitely bigger than 3. So we don't care about this side, because apparently the only interval which it's increasing is from negative 3 to 3. So we only really care about this. We also don't care about this side, because this side is decreasing. So what we care about is here. We gotta see what this is here. So f double prime negative 1. F double prime negative 1. What's that? We'll come here, plug it in here. So we had 2 times negative 1 squared, that's 2. And 2 minus 36, that's a minus. But then a minus 1 to the 5th, that's another minus, because that's an odd power. So we have minus divided by minus, that's positive, that's good. It's a positive number. It's a positive number, that means this is increasing. Or it's not increasing, it's concave up. It's concave up at least from negative 3 to negative 1. However, we do have to include the 0 here, because we know that at 0 it's undefined. So we pick 1. So here's our 0. If we pick 1, what happens here? You'll see. You get 2 minus 36, that's negative, and a positive. Negative by positive is negative, so it's concave down. So 0 here, so it would be from negative 3 square root of 2 to 0. That's concave up. And since negative 3 to 3 is increasing, that means from negative 3 to 0 it's also increasing. And since negative 3 square root of 2 is bigger than, or smaller than negative 3, and we know that from negative 3 square root of 2 to 0 it's concave up, then also from negative 3 to 0 it's concave up. Therefore, so by comparing these two tests, the first derivative and the second derivative test, therefore, from negative 3 to 0, it is both, for f of x is both increasing and concave up. Again, we want to find when it's increasing on the interval, when it's both increasing and concave up. Since in the first derivative test we saw that from negative 3 to 3 is the only place where it's increasing, we could care less about negative 4, negative 5, all the numbers to the left-hand side of negative 3. We don't care because it's decreasing. So here, I picked negative 6, but really we don't even care about that because negative 3 square root of 2 is smaller than negative 3, and we don't care about that side. So we don't even have to worry about this. Also, we don't have to worry about this side because from 3 to infinity it's decreasing. And 3 square root of 2 is bigger than that, so we don't care about that side either. All we care about is from negative 3 square root of 2, so all we care about is the interval between negative 3 square root of 2 and 3 square root of 2. Because that's where it's increasing here, from negative 3 to 3. Okay, negative 3 is inside of negative 3 square root of 2 and 3 square root of 2, so we do care about that. So now that we know that's increasing, we know that at 0 it's undefined. So I picked the test point here, negative 1, and that means it's concave up here, and 1 here, it's concave down. So we know that from negative 3 square root of 2 to 0, it's concave up, and we know that negative 3 is between negative 3 square root of 2 and 0, so therefore from negative 3 to 0, it is concave up, and from negative 3 to 0, it's concave up, since negative 3 to 3 is, increasing, since negative 3 to 3 is increasing. Therefore, negative 3, 0 is both increasing and concave up, that interval.